Hello everyone, and today I wanted to go over my research project for this semester. My research project was titled Securing SFM Systems Using Generative Modeling. However, I just like to call it You're Missing the Point. So before we talk about the bigger questions that this project aims to answer, let's talk a bit more about the underlying concepts. One of them is point clouds. So what is a point cloud? Well, a point cloud is just a way to represent a 3D structure. As you can see here, this is a 3D representation of a building, and they're generated by taking a bunch of 2D images, usually at different angles, and then trying to match up the different points in those images and projecting them into a 3D space. And that is what a point cloud is. And they're used in many technologies. Technologies such as self-driving cars, where point clouds are used to help the car understand its environment and where it is in relation to other objects. In AR/VR systems, it's used to understand where you are in relation to your environment. Let's say, for example, your living room. And these systems are becoming more and more widely adopted. While a lot of time and energy has been spent into making these systems more efficient as well as more available for a broader use, not as much effort has been spent in making these systems more secure, specifically secure against a type of attack known as scene recreation attacks. This is a type of attack where you can take the original point cloud, which is just supposed to have structural information, and then recreate the images that were used to generate that point cloud. While in some contexts this attack doesn't lead to any loss of meaningful information, in other contexts such as our home, it can be a huge invasion of privacy. Also, as these systems are being used in more secure installations such as military bases, it can also constitute a security threat. So after understanding these concepts, we can begin to take a closer look at the questions we're trying to answer in this research project. So the first one is, can we prevent these attacks by adding random noise around the existing point cloud? And secondly, can we do it, or can we add noise in such a way that it doesn't harm the overall accuracy of this model? So to answer the first question, we decided to create a proof of concept demonstration where we took an existing point cloud and added lots of random noise all around it. And as you can see here, by adding this noise, we were able to prevent a scene recreation attack from occurring. However, because these points were added randomly, we also lost a lot of the accuracy of this model. So to preserve this accuracy, we are going to use deep learning. Specifically, we're going to use deep learning to understand how this added noise will affect the actual accuracy of the model as well as its susceptibility to the scene recreation attack. And then we're going to use this relationship to optimize the added noise. Specifically, we're going to be using a type of model called diffusion modeling. This is a type of model where we take the original point cloud and then keep on adding noise onto it until it's just random noise. And then we train our network to learn how to take this random noise and recreate the original point cloud from it. However, we slightly modified it where instead of just learning how to recreate the original image, it will also learn how to do it in a way where we decrease our susceptibility to the scene recreation attack. While this is an incredibly powerful model, it is also very complex, and it takes a long time to not just train, but to sample from as well. And as a result, we were not able to fully finish this model by the time of this recording. Therefore, I would like to continue developing this model further in the future, as well as making this model available to other developers for feedback as well as integration with their existing pipelines. And finally, I would also like to look for other methods that might yield similar results while reducing the time it takes for the development. Thank you all so much for your time, and I would like to take a second to thank Professor Bohan for being my mentor and guiding me through this process, Mr. Nan Wu for helping me answer a lot of the questions I had while I was in development, the GMU Oscar office for teaching me about research as well as providing funding for this entire project, the ORC office here at GMU for providing computational resources, and all others who have made this possible, including my classmates, my friends, as well as my family. Thank you so much.